The mining of cryptocurrency can damage the PC parts if you work in the same PC and mining, ? So let's look at this from perspective of why do components get damaged regardless of how they are used. Because it doesn't really matter that much what kind of workload they're under. They get damaged from heat. Heat causes a few things. Heat causes rapid degradation of parts. It is a catalyst. And heat also causes things like fires. So in extreme scenarios, you could have not a fire like a house fire, but a fire like a component, like a power component just popping. VRM pops, is kind of what you would say. So a good example would be a capacitor. Capacitors, a lot of them can take about 105 degrees Celsius. Some of the better ones might be rated for 10,000 hours at 105C. Some of the cheaper ones might be rated at 5,000 hours for 105C. These are real numbers for actual capacitors you find on boards. Some of the B3, actually a lot of the B350 motherboards use 5K capacitors that's at 105C. So if you're running higher temperatures, doesn't matter if you're mining or not, for prolonged periods of time, you could be eating away at the lifespan of those components. You are far more likely to chew away at the lifespan of capacitors than a MOSFET, unless it's a bad batch of MOSFETs or bad batch of power components like EVGA encountered with their ACX cards a little over a year ago at this point. And that's unlikely, though. Generally, you're looking at other component failures. VRM components like chokes and MOSFETs can take 125, 150C really before they start derating hard. So yeah, caps would be the thing to look at. And this comes down to how the cooler is designed. So each card's going to be different. Cards that don't have a good heatsink contact to those power components are going to be under a lot more duress. So if you have cards that you can adjust the fan speed to keep the GPU core temperatures low, they're not cooling the power components, you can still have a catastrophic failure. And when they fail, primarily will hinge on how hot those components get that are rated for lower temperatures, like capacitors. 105C is relatively low compared to other power components. So it's not going to be an instantaneous failure. Another source of failure we've seen, so I was looking at some photos of mining machines that had burst aflame via Twitter. And if you look at a lot of those, they tend to fail from overdraw on the power cables. So that's a scenario where you are either exceeding the current rating of the power supply for that rail, or you are exceeding the current rating for what the gauge of the wire can withstand. If you're using, and this is true outside of mining as well. So if you're doing high-end overclocking with power mods or hard mods on the card, like we did with Vega 56, if you were to then take a smaller gauge wire that's not rated for as much current and plug it in, there's a chance you could burn out the wires. And hopefully you have a good power supply that can help deal with that sort of thing. But that's generally the type of failure you see is overdraw or power component failures. It is possible for the GPU or the memory to burn out, but unless you've modified the card in a way that has interfered with the contact of those components like HBM to the cooler, it's pretty unlikely. The card has protections to throttle itself once it gets warmer, unless you enter a runaway thermal scenario where you've got racks and racks of these things and they're in a high ambient operating environment, 40, 50C. Unless you're in that scenario, power components are still where you'd look for a failure. And then after that, probably fans, depending on how many hours the fans are rated for. If you're running fans at high speeds for long periods of time, you're going to chew through their rated lifespan a lot faster. And when fans fail, other components will fail unless they have a mechanism built in to trigger a shutdown, which I can't name a card current gen that does that. So yeah, those are the main things that fail. It's a really interesting topic, and it's probably worth a completely separate video with some testing because I've done some testing on this kind of stuff. So I will leave that there for sake of getting to other questions. And there's a lot I've left out here, and I'm sure there's stuff that I'm not thinking about right now that we could include or talk about in the future, but we gotta roll through some more questions. So if you are interested in that topic more, not just cryptocurrency mining, but hardware failure from load in general, let us know and we'll look into it. I'll note one more thing here. With regard to any amount of sustained load, whether that's 3D rendering or mining, you can stay a lot of the keep a lot of the negative effects at bay by modifying the card with just a simple power offset. If you tell it to draw something like 70% of its power, it is going to draw well below what it's rated to handle. Those power components should be, if you've left it unmodified and it's not a terrible, terrible cooler design, they should be fine. So if you are really concerned about your rendering machine or your mining machine or whatever with high thermal environments, if you're concerned about it burning up, consider lowering the power target, increase the fan speeds, make sure there's direct cooling on the back of the card or somewhere to get rid of radiative heat off the backside of it. And then you can, of course, tune clocks if you had to from there, but undervolting, of course, also an option, although that doesn't really work that easily a lot of the time, especially with NVIDIA cards, but easier to do through power play tables. So yeah, that's some basics for you. But the thing to take away here is that heat is the catalyst for everything bad in computers. Or unclean power, I suppose. You can pretty much solve all of the things you'd be concerned about with good cooling solutions and with good power supplies. And once you've done that, there's not much more you can do. If you have fire concerns, a good power supply will solve a lot of those, and cooling will keep the heat away, because heat causes fire. And it's not like, it's not as literal as how high of a temperature do you need for metal to catch on fire, because it's really freaking high. It's more a question of what is catalyzing from that heat, what's going on, what chemicals are breaking down, what power components are starting to fail, and then what is their catastrophic failure mechanism? Is it popping? Is it like bursting into a puff of smoke and brief flame? They're pretty uncommon things. You don't really need to worry about them, but that would be kind of the catastrophic failure I think you're talking about. You don't really have VRM components when they fail. It's not like you start getting artifacting. You don't just start seeing memory artifacts or texture artifacts in your graphics. It just dies. It goes black, it dies, shuts down, whatever. There's no gradual failure of a VRM component. It's just gone. So that's kind of, I think that should give us a good starting place to look into more later. I really like that topic. A lot of what we do is based around it, like thermal testing, power testing. So I'd love to talk about it more. So thank you for watching. As always, you can subscribe for more. If you'd like to help us out directly, you can go to patreon.com/gamersnexus, or you can go to store.gamersnexus.net/modmat to pick up a mod mat like this one. I'll see you all next time.